and we are going to be doing task 6. So for the task 6, we are going to be doing a couple of updates, and we are going to be creating a new file. First, we are to update the base model, and we are to create a declarative base, which is coming from SQL Alchemy. And then we are to create this class attribute and ID, and created that and updated that. This for database. So if we go to base model, I already have my base model opened. I'm going to first try to import declarative base and then datetime object and so on for the class attributes. I'll just do this fast. And then after doing this, I think I should reduce the screen. We are going to create the declarative base. So this declarative base is necessary for mapping the schema for SQL Alchemy. And the next one is to create all these class attributes. So I'll do it here, say ID. It's not going to have more than 60 characters. The primary key is going to be ID, and it cannot be no, it must have a value. And then the created that is going to be also be a column, but it's going to be of date time, and it cannot be null. And the default is going to be datetime dots. Now the UTC now is duplicated, so we have to now be using now. And then the other one is updated that, which is also the same thing with created that. So now we are told to move the models.storage.new from the constructor to the save method. So that's this. We are going to have to move this from here and move it to the save method, and we are to call it before calling the storage.save, which means we are going to be taking out this line. And the next one, which is the fourth one, here we are told to manage the keywords argument to create instance attribute from this dictionary. That is, if name is given as California, it should create an attribute name, and the value should be California. So with this update that we've made there, if the name is given, it's going to check if that name is an attribute of the given class. If it's an attribute, then it's going to set the attribute. So the check that we have here covers this all. And then the next one is the fifth one, to update the toDate method to remove this SA instance. The reason for us doing this is that when using SQL Alchemy, when the class is created, the table is created, this SA instance is added to it. So when we are converting it to date method, we don't want to return it. So all we can do is to say dictionary, and then we pass in the key. I believe we can use dictionary.pop, the pop method, right? Yeah. But so I'll change this to braces. Code dictionary.pop. That way we are not going to be returning the dictionary that contains this SA instance. And then the next one is the sixth one. We are going to be adding a new public method, which is delete, that is going to delete the current instance from the storage. So we call create delete and we pass in self, and we are going to have to import storage here just to avoid circular imports. So we call storage.delete and we pass in self. So next one is to update the city model. So we go to city, closely. So for the city model also we have to import column, foreign key and string from SQL Alchemy. SQL Alchemy import column, foreign key and string. And also we have to import base model and base, because city is going to be inheriting from base model and base. Okay, I guess I have it here already. And it has to be in this particular order. So we are going to modify this to, we are going to use this table name, which is an attribute from SQL Alchemy that we can use to customize or specify the name of our table in the database. And then what is it? Okay. Here we are going to be creating the name and state ID attributes. So this state ID is going to be the relationship between state and city. That is, for every city is going to be created from a state. No state can exist on its own without, I meant no city can exist on its own without a city. So we're going to say the name is going to be a column, string of 128 characters, and it cannot be null. Similarly, for state ID is going to be column and also a string of 60 characters, and it's going to be the foreign key, and the relationship is the state.id, and it cannot be false. So like I said, the reason for this state ID is that cities are going to be created from states. So no city can exist on its own without having a city, without having a state to fall under. And then the eighth one is for the state. We are going to update the state to customize the table name and name attributes. So similarly, we are going to import, let me just copy this from here. Okay, what we need here is column and string, and then also we need to import from SQL alchemy.orm, we import relationship, and Where's my test? So first we set the table, so the table name as state, and the name is going to be column, and it's going to be a string of 128 characters, and then it cannot be false. And then here we are told to create a class attribute that represents relationship with the class city if the state object is deleted. Then all linked city objects must be automatically deleted. Also, the reference from the city object to this state should be named state. And we are told to do this depending on the environmental variable. So what we can do here is we are going to say if get env need to import if the environmental variable is HBMV, if the type of environmental variable is DB, that is if we are saving to the database, we are going to create a relationship between cities and state by okay, we're going to add the cities attribute, and it's going to be the relationship. We pass in city and we say backref will be state, and cascade will be all, and then delete or orphan. Did I get it right? Delete orphan. So here the city specifies the related model, indicating that a state instance can be associated with multiple city instances. And then the backref equal to state is saying that city instance can access its associated state instance using the attribute specified in the backref, which is in this case state. And cascade, or this means that all changes, including instance updates and deletes to the state instance, will be cascaded to associated city instance. And this delete orphan, it indicates that if a city instance becomes orphaned, that is if the associated state instance is deleted, the city instance should be deleted as well. So that is for DB storage. We are going to do similar thing for file storage, but we are going to be using a getter attribute that is going to return the list of city instances with state IDs. That is, we are going to return any city that is associated with that particular state. So we are going to say else if, that is if the type of storage here is no longer DB, then we are going to set a getter attribute that return the list of the instances. So we are going to say at property cities, and then we pass in self. So in this getter method, we want to return all cities that are related to the current state instance. That is, assuming that the state is California, we want to return all cities within California. So I'm going to have to make the imports inside. I'm going to import models, and also from models.city, I will import city just to avoid circular imports. it gives me a lot of headache. So we are going to set um, an empty list called city list. That is going to hold the list of every city that is associated with the current state. And then we are going to first retrieve all the values of a city, of the city model. And then, okay, let's do it first. So we are going to say for city in models dot storage dot all, and when we pass in city, we get all the values. So since we know that the state ID is the relationship between one state and all cities in that state, we are going to compare the current state ID with the state ID which is an attribute in the city model. So we are going to say if city dot state ID is equal to self dot ID. That is, when we say self dot ID, we are referring to the state, the current state, and we are checking if the state attribute of the particular city is the same with the state ID. If it is, it means that the city is associated with the current state. So if we find one, we are going to append that city to the list of city for the current state, and finally we return the city list. And then we are going to create a new engine DB storage, and we are going to be creating it inside the engine. So I'll go to engine. Here we have file storage, and I'll create DB storage. And then, okay, we are going to create these attributes. DB storage, create an engine class attribute engine, set it to none, sent in for session, and set it to none. So we are setting them to none for now, and we are to create a public instance, and then we create engine, and the engine must be linked to a MySQL database, and we are to use the environmental variable to retrieve user password, host, and database. Okay, so create the constructor, and we pass in self, and I think we have to import. So now that we've gotten all this, and we are going to create a connection string for the database, and we are going to say MySQL plus you are using this should be inbuilt, yes, MySQL DB. So, and then we are going to create a connection to the database using the create engine and set it to private attribute this self dot this engine. So we say self dot engine is equal to create engine, and then we pass in the DB URL, and then we pass in this pull propane and set it to true. Okay, I'm doing this outside. And we have to go import the create engine. So we say from SQL alchemy import create engine. So this pull prepaying, what is used for is to check if a connection is alive before handing it over to the application. So it's always before anything happens, before engine is created, it first checks if the connection is active before it goes on. And then the next one is to create this public method all, which is going to return a list of all objects depending on the class name. Okay, if a class name is passed, it's going to return all objects of that class. If class name is not passed, it's going to return all of the classes, all of the models, that is all of the tables from file storage or DB storage. Okay, before that, I think we are missing something. Yes. Okay, we are missing this line. Supposed to drop all tables if the environment variable is HBNB, if the environment variable HBNB is test. Okay, so and this has to be in the constructor. So we are going to again say if get env HBNB, what is it? HBNB env is if is equal to test, then we are going to call base dot meta data dot drop all, and then we pass in self dot engine. So I guess the reason for this is so that during tests we can just drop all the tables to ensure a clean state for each test run. And have to import base. I should also import base model too. Okay, so now we can move on to the all method. Just like I've explained before, the all method, we are going to return objects of a class if the class name is given. If it's not given, return the objects of all classes. So I'll just copy this So first, we're going to create an empty list that is going to hold the objects. So I'll call it objects list, set it to an empty list. And then first I'm going to check if the class name is provided. That is, if we are trying to retrieve all objects for a given class. So I'll say if class, if it's provided, we are going to check if this class name is a string. It could be a string and it could be an object. So we say if the class name is a string, we are going to try to convert it to an object. And to do this, we are going to use the globals keywords, which is a dictionary, and then we pass in self. So this globals method, it returns a dictionary of all variables, classes, functions, and modules in this current module or file, which is the db storage.py. It doesn't return variables from the entire application, it's just from this current file. And then now if we pass in this class name, what we are doing is to try to retrieve, because we know that the class name from here it is a string. If we pass into global, we are retrieving the class object in this current scope. So for us to do that, we still have to import all of the classes, and then I'm going to save it as class again, and then we are going to accept a key error, and then we pass. Because if there is no class in our current scope that matches the name, a key error is going to be thrown. Thus, the pass statement is to ensure that the execution continues. So next, we are going to put another check to ensure that we only query for all classes that only inherits from base. That is base, not the base model. We know that base is from declarative base, which is all classes that are mapped to the table. That's what we want to check. So we are going to check if this class is a subclass of base. If it's a subclass of base, it means that the class exists in the table. So we are going to say object list is equal to self dot section dot query, and then we pass in this class name, and then we return all of the objects. Then if the class name is not given, it means that we are to query all objects of all the subclasses of base that are mapped to the table. So we are going to iterate over all the subclasses of base. So we are going to say for subclass in base dot, we use this dunder method subclasses, which is going to return all the classes that are mapped from this declarative base. And then we are going to query to retrieve all objects for each class, and then we call extend method to append all objects of each class to the list. So we are going to, we know that here, if class name is not given, it means that this object list is still empty. So after iterating through each classes that are mapped from this declarative base, we call object list and we call the extend method of it. And then we pass in self dot section dot query, and then we pass in subclass, then call all. Here we know that should be sub. Know that subclass represents each model that are mapped from base, which is the city, the state. So for each iteration is going to search for it in the table, it's going to retrieve it and it's going to append it to this object list. And for the next one, it's going to do the same thing. And then the next thing we are going to do is we know we are for this all method is supposed to return a dictionary containing all the instances like in file storage. So what we are going to do is to create an empty dictionary and we call it object dict. And then we are going to iterate through this object list, be it from when the class name is given or when we are retrieving for all. So we are going to say for object in object list. So what we want to do is the same thing we did for file storage, where we know that this is a dictionary and the dictionary has a key and a value. So we have to first form the key, and the key is supposed to be class name dot the object ID. So it's form a key. I'm going to use the format method, and then I'll retrieve the class name and then also the object ID. So now that we've customized the key, what we want to do is to now set the key as key in this object dictionary and then set the each object as value. So I will say object dictionary and then we pass in key and then we set each object as value, and then finally we return the object dictionary. So next is to create these three methods. I'll copy them and paste them here. So the first one is new, which is going to be responsible for adding an object to the current database section as stated here. So we just say self dot section dot add the add method, and then we are going to do for save. The save method is going to commit the current transaction in the section, that is saving any changes made to the database. So we say self dot section dot commit, and then the last one is the delete method, which is going to delete an object from the section, that is if the object is provided. So you're going to say self dot section dot delete, we pass in object. All these add, commit, and delete are methods of the SQL alchemy. And the next one is to create the reload method. So for this reload method, after we create this reload method, it's going to be responsible for ensuring that our database schema is synchronized with the current state of the SQL alchemy models and also provide a fresh database section. So we are first going to start with calling base.meta data dot create all, and then we pass in self dot engine, and then we call section factory, and then we set it as section maker. We have to still go and import this, and then we say we bind it to, can I spell bind? We bind it to self dot engine, and then we say expire on commit, we set it to false. Okay, expire dot commit, we set it to false, and then we are going to say that the section is equal to scoped section, and then we pass in this section factory. That is this section factory, we pass it, and then say self dot section is equal to section. So this is where we are, you know that before now this self dot section has always been none. So here we are binding it, we are setting it as this section. So um the reason for this reload method is just that is particularly useful in scenarios where changes to database schema or section state need to be reflected during runtime. For example, in web servers, it's very common for changes to be made to the database schema or the state of database section while the application is still running. Like new tables can be added, existing tables modified, constraints altered. So when or if these kind of changes should occur, the application needs a way to synchronize the database schema with the updated changes without shutting down or restarting the application. Also, to maintain consistency and data integrity all through the application during, before, or after database sessions like transactions, queries, updates, and so on. So this reload method provides a convenient way to reset the database schema and create a fresh database section, allowing the application to adapt to changes in the database structure or section state without interruption. This ensures that the application remains responsive and can continue to serve requests while accommodating dynamic changes to the database. And also we have to go and import all the models and the section maker section scope, because without importing all the models, this line, this is not going to work. It's going to throw an error. So first start by importing section scope and section maker. Also from SQL, I think that should do. And then the next one is to update. Okay, go to models, the thunder init of models and update it. So close the engine and go to init here. We are going to update it in such a way that if the type of storage is database, we are going to import db storage and set storage as db storage, and then if it's not database, we are going to set it as file storage. So we are going to say if, okay, I guess I have to import. So we're going to say if get env should be hbnb, if the type is, if it's db, we are going to say import db storage, and then we are going to set storage as db storage, and then if the type of storage is not db, then we are going to import file storage and set it as file storage, and then finally we call this storage the reload, which is the reload method. We know that the file storage and db storage both have reload method. So what the reason for this is we are dynamically selecting the storage engine based on this environmental variable. This way we use flexibility in choosing a database backed storage solution or a file based storage solution, which is file storage, without modifying the application code. So this approach, it makes it easy to switch between different storage implementations depending on the deployment requirements or development preferences. Because if we don't do this, it means we have to go back to console.py and start doing modifying all these. So by doing this, by setting it this way, the application does not know concern itself of how the type of storage is. The application does not concern itself of how it's using a particular storage. So again, let's see if that's all. Okay, and I guess that is it. The next thing is we are going to test this. So I'm going to copy this line because I'm using git bash. This is not going to work for me, so I will say Python. Here we are setting the type of db storage as db, so which means this is going to be a database operation. So if I copy this and if I should run this, okay, there's a typo here in line 79, db storage 70. Okay, my bad. So I will clear and I'll run this again. Why? State is not mapped. Okay, true. My bad. So we're passing base. Let's try again. It's not defined. Really sorry. So I'll import it, and again this one says column name cannot be known. So the reason that I'm getting this error where name is set to none is, I think, is coming from base model. So is from this part. This is not supposed to be under this other condition. It's supposed to be on its own. So when I start it back this way, and if I test again, we should be able to create this. Okay, so we see that we are creating a state, and then I'm going to go back and run the second one to retrieve all states. And we see that we're retrieving all state, but I don't want this SA instance, so we're going to update something to be able to remove this SA instance. So in order to remove this SA instance, we know that when we say echo all, and that is we are piping it to console.py, and in console.py, the all method, if I can find it, in do all um, is current storage.all. So we have to go to db storage, and then we have to go to the all method and modify it. So to remove the SA instance keyword, I have to make sure that before I set the object as value and the key as key, I have to check if the okay, so we see that is state, so this is related to the state, so I have to check if the object, the name of the object is state. How am I going to do this? So okay, I think I'll do it down here. I'll say try, I don't know if it's necessary, so I'll say if object dot class dot name is, if it's state, then what I want to do is to use the delete keywords to delete the object dot, I will copy this and then say object dot SA instance, and then I will set the object as value. That way we won't have this SA instance key. And then if the object name is not state, we just equally set it. So if we should go here and try again, I first have to create another one, DB storage. Okay, so forgot to add exception. If I create state, and this one is ID is 60, and if I say all state, we should still have some with the instance. Okay, so we say that we are retrieving them but without the instance, so which means before we retrieve them we delete the instance key. So the next thing is to create a city by using one of the states that we created here. So I'm going to pick one of the state ID, and I'm going to come here and I'll take this one off, and I'll paste the city, the state ID, and I'll change this to, I'll clear this then, and the type of storage is DB. Press enter. This should give us the state, and the name of the state is San Francisco. So next one is to try to retrieve all the cities. Okay, we're still getting this SA instance. Shouldn't be getting that. All states. Let me see. It should that be DB storage. Or maybe what I can do here is to just, if I take out this and remove these states, this conditional, and just, this is going to try to first delete this SA instance and then set the object to the key. So, but if the object does not contain this SA instance, we are catching the exception here, and yeah, this should do the trick. So I'm going to try to retrieve all city. Okay, so now we see that we can retrieve the city without having the SA instance. And then the next one is, okay, so we are going to create another city that is associated with this same ID. So which means we are going to have one state that is associated with two cities, San Francisco and San Jose. I'll clear my terminal and I'll press this here. And then let's retrieve all the cities directly. Of the password again, HPFB. Okay, so we are seeing that we've got the city San Francisco and San Jose, and the state ID is the same, which means they are coming from the same state, California.